All right, y'all. So 9.1 deals what we call the composition of functions. And so, y'all, when we talk about a composition of functions, what we mean by this, so the composition of functions so this is when one function is used as the replacement for another function. So what you're talking about, I'm gonna give you two types of symbolism they use. So the first one looks like this: F compose G of X. Now this ain't a O, this is like a almost looks like a little degree symbol. But y'all, F compose G of X is really F of G of X. So when it looks like this, the function of G of X is put into each of the X's for the F function. So the function G of X is put into each X for the F of X. Now, the second one, they sort of reverse it, and it is G compose F of X. So this means G of F of X. So y'all, when it's like this, the F of X function is put into each X for the G of X. So the function F of X is put into each X for the G of X. So the order does matter. So y'all notice, if I got F composed G of X, then we're going to put the G of X into the F. If I got G composed F of X, then we'll put the F of X into each of the variables for the G of X, okay? Now, we're going to start out, they're going to give us numbers here. So they might say find F of G of 7 or whatever number. So if numbers are given, y'all letting one in real quick. So if numbers are given, and I'm doing, say, F of G of some number, so we'll let A represent any number, okay? So if I have this style, the first thing I would do is find G of A. So whatever number they give me, I'm going to plug into the G equation. All righty. Once I figured out what this G of A equals, I then plug that value into the F of X. Okay, so if you got f of g of a, numbers are given for the variable, plug it into your g first, and then take that value and plug into the f. So it's almost like two-step substitution type problems, okay? Now, if we got g of f of x, g compose f of some number a. Well, if it's g of f or g compose f, then the first thing I do is I find f of a. So I find my f of a. It's almost like order of operations. A into the f, and then that value into the g. Okay. So the second step here, plug that value into g of x. So they're not as bad as all these definitions I'm giving you when we actually work the problems. I think it's a lot easier when they give us numbers than when they don't, okay? So let's play with some of these examples where they are actually giving us numbers. All right, y'all. So this first example, they want us to let f of x equal negative 3x minus 1. G of x is going to equal x squared minus 2. So what they want us to do, they want us to find f compose g of 7. So remember, if you're looking at this, this would be like a f of g of a 7. So work it like order of operations. Work the g of 7 first, get that answer, put it into the f. Okay, so like we said here. So that means the first thing we got to find for this problem is g of 7. So first, we're going to find g of 7. Okay, so g of 7 will equal the g function, and we're going to put a 7 in for that x. So that'll give me a 7 squared minus 2. All right, so working that, following an order of operations, I'm going to do the exponent first. So 7 times 7 gives me 49 minus 2, which gives us 47. So g of 7 is 47. So that means that we're now going to find our fx of that 47. Okay? Because we're going to plug the value we got from g into f. Well, y'all, g gave me 47. So that means second, we're going to find f of that 47. Okay, so f of 47 will equal the f function, and we're going to put a 47 in for that x. So that'll give me negative 3 times 47 minus 1. All right, y'all, so order of operations here. Let's see. I think that's a negative 141 minus 1. And let's see, negative 141 minus 1 gives us a total of a negative 142, which is our final answer. All right, so 7 into G, get that answer into the F, okay? So y'all got questions on that one? All right, not seeing none. So y'all, that's what we're going to be doing with the numbers. And keep up with the order. Are they giving me F compose G, or are they giving me G compose F? So there'll be three of them with us getting numbers. And then after that, we'll look at them when they just give us the F of X and G of X, okay? So for this number 2, we're given F of X equals 2x plus 4. G of X is going to equal X squared minus 3x minus 5. And on this one, we're going to find G compose F of a 7. Okay, so remember, this is like G of F of 7. So we start with the F of 7, get that answer, and then plug it into the G. So that means the first thing we find is our F of 7. All right, so we're going to find F of 7 and then take that answer and put into the G. So y'all, F of 7 is going to equal my F equation, and we're going to put a 7 in for the X. So that'll give us 2 times 7 plus 4. All right, y'all. So on that one, starting with the multiplication, I get 2 times 7 is 14 plus 4, which will give us 18. So now we know F of 7 is 18. So secondly, we will find G of that 18. Okay, y'all, so just keep up with the order on these, okay? They always sort of go right to left. 7 into F, that into the G, okay? So G of 18 is going to be 18 squared minus 3 times 18 minus 5. So y'all, G had 2 X's, so I had to put that 18 in for both X's. All right, so let's see, working the exponent first. 18 squared is 324. Minus this 3 times 18 is 54. And then minus my 5. So y'all, let's see what we get. 324 minus 54 minus 5 gives me a total of 265. And that would be our final answer. So notice we done an F of G, where I put the number into the G, then the F, and we done a G of F, where I put the number into the F, and then we found our G. Question on that. All right, so this will be the last one with a number, and then we'll sort of look at new things for the last 3, okay? So for this one, we're going to be given F of X equals 3x plus 4. G of X for this one equals x to the 3rd. They want us to find F compose G of a -4. All righty, y'all. So for this one, remember, this is like F of a G of -4, which means I start with my G of -4, get that answer, and then plug that into my F. So first, we're going to find G of -4. Oh, y'all, so G of -4 will equal, well, G is an X cubed, so that's going to be a -4 cubed. So that'll be a -4 cubed. So let's see, negative times a negative will stay negative because you got 3 negatives. And then let's see, 4 times 4 times 4. So that'd be what, 16 times 4. So that'll be
64.
a -64. So that -64 now goes into the F equation. So y'all, we're finding F of that -64, okay? So F of -64 will equal 3 times -64 and then plus 4. All right, y'all, so let me see what I get there. What was that? 3 times a -64. That's going to be a -192 plus my 4. So that's a negative something. 192 minus 4. I mean, yeah, plus 4. That's going to give me what, a -188. All right, y'all, and that would be our final answer on that. So questions when they use the numbers. So the first three, that's all they're doing to you. They're giving you a number, plug it in, make sure you're in the right order, get that final answer and be done. So what I'm going to do now, before we can do the next three problems, they deal with domain, but we're going to look at what we call interval notation for the domain. Instead of us doing X, such that X is a real number and X cannot equal 5 and stuff like that, what we're going to learn for the domain is what we call interval notation. So in interval notation, we use parentheses and infinities to represent all real numbers. So in interval notation, all real numbers is represented by, so y'all, the furthest I can go left is negative infinity. And the furthest I can go to the right is positive infinity. So if your answer is all real numbers, you're going to use this symbolism right here, from negative infinity to positive infinity. That means all your numbers that we can imagine left and right, make that true. So to exclude numbers, from the domain, we use the union. So the union is like a U shape, okay? So that union means and. Okay. Now the thing you got to realize in interval notation, if you're excluding a number and you don't want it counted, you use curvy parentheses around the numbers. Okay. So I'm going to show you how we would exclude a number A. So for example, to exclude any number A from the domain, we would have Now, they're always going to start at negative infinity, okay? When you're dealing with functions. So to exclude this a, I would go from negative infinity to the a. I use curvy parentheses. And then I would use that union and then open up parentheses with the a. So the number you exclude, because see, y'all, when you use curvy parentheses, that means it does not include that number. Now, infinity always uses curves, okay? Because it's not got a, there's not like a stopping point for infinity. So it always uses curves. But when we exclude a number, we use curvy parentheses. If we wanted to include it, we would use them bracket things. So that's how you include a number with brackets. So since we're using curvy parentheses, that excludes the number. And then from that number, you would head towards positive infinity. So it still starts at negative infinity, ends at positive infinity. But now we have excluded the number a. So we're saying our domain goes from negative infinity up to a, but it does not include the a. And it goes from the other side of the a, where it don't include the a, and it heads off towards positive infinity. So y'all, that's the lingo we'll use for the domains on these problems that we're about to get, okay? Now, guess what? Later on in life, if I got to exclude two numbers, I would have two unions in it, okay? And we'll see that, like I said, later in life. So, let me get us started on these examples. Now, the thing about these examples, they're not giving me a number to put in, and they're wanting domains on them, okay? So these are a little bit trickier. And guess what? They want us to find f compose g of x and g compose f of x and the domain of each. So first we'll find f of x, f of g, then we'll do g of f, and then we'll look at the domains of those, okay? So the first thing I'll find is my f of g. So let me get our functions here. F of x is going to equal x plus 17, and g of x is going to equal x minus 17. So let's start with f compose g of x. So y'all, what happens here when they don't give me a number to put in? What that means is I got to take the g of x function and put into the x of the f of x. So we're going to put the g of x function into the x of the f of x function. Okay, because they didn't give me a number for the g of x, so I can't do nothing to that. So that means I'm going to take this whole function and put into that x. Okay, so f compose g of x is going to be my f function, which is x plus 17. But remember, I got to put the g of x into that f. So putting the g of x in for that x, I would put the x minus 17. And then I still have my plus 17. So right here, I put x minus 17 into the x of x plus 17. So y'all with me? This whole thing went into that x. Now, we can simplify this though. So y'all, what does x minus 17 plus 17 simplify to?
Is it X?
It's an x because these things right here are going to cancel. So that whole thing equals x. Nothing else we can do to that. So that would be the final answer. So let's look at it the other way. Let's do the g of f of x. So g compose f of x. Now remember, we're going to put the f into the g. So g is x minus 17. So we're going to take this f right here and put it into its x. So that'll give me x plus 17. That's the f of x I'm putting in. And then at the end is a minus 17. So for this one, I put x plus 17 into the x of x minus 17. And look at that. Once again, those are going to cancel. And I end up with just an x. So y'all's first one, like y'all's number 4, it'll be really like this one. They'll give you x plus a number, x minus that number. They're going to work out like this, okay? So now let's look at the domain. So the domain of f composed g. So y'all, when I did f composed g, I had x minus 17 plus 17. I ended up with an x, but my question, given these functions right here, what's that domain? So let me ask y'all this. Do y'all see any fractions? Well, I don't see no fractions. I got an x of 17 and a negative 17. So remember, since there's no fractions on this f composed g, that means my domain is all real numbers. But remember now, to represent all real numbers, I'll use negative infinity to positive infinity. So how about the domain of g compose f of x? Well, g compose f of x, we had an x plus 17 minus 17. I mean, they're the same thing except the order of the adding and subtracting. So that means the domain of g compose f of x is all real numbers, which is negative infinity to positive infinity. Okay, so watch out. There's like 4 problems in here. F compose G, G compose F, and then the domains of each, okay? Well, y'all, these ones are a little trickier than the others. All right, so we're still going to do the same thing. We're going to find our f of g, g of f, and the domain of each. This time, f of x is going to equal x plus 3. G of x is going to equal 2x squared minus 5x minus 3. All righty. So let's start with f composed g of x. Now remember, I can't do nothing with g of x. They didn't give me a number. So that means I'm going to take the whole g of x and plug it into the x on the f. So that means plugging this into that x, I'm going to have 2x squared minus 5x minus 3. And remember, that's g of x I plugged in, and then I still got a plus 3. Okay, so on this one, I put g of x into the x of f of x. Which means really, when you plug this whole g of x into that x, that means I'm finding f of a 2x squared minus 5x minus 3, because that's what I'm plugging in for that x, and then I add that 3 at the end. So the question, what does this simplify to? Oh, and that does simplify a little bit, y'all. What like terms do I got here?
Sorry, I've been writing this down, but could it be 2x squared minus 5x?
Sounds good to me, y'all, because remember that negative 3 and positive 3, these numbers are going to cancel again. So good job, 2x squared minus 5x.
Thank you.
All right, so then we go the other way, and y'all, we're going to have fun on this other way on this one. G of f of x. This time, since they didn't give me a number for f of x, this f of x has to go into the x's of the g. But y'all look, g's got 2 x's. So we're going to put an x plus 3 here and square it, and then an x plus 3 there. So we'll have 2 times x plus 3 squared minus 5 times x plus 3, and then at the end, minus 3. So this one, we did the other thing. We put f of x into the x of g of x. And how about the x's of g of x? Okay, because that had 2 x's on it. So now, here's where I get people. Because y'all, let me tell you, the very first thing you got to do, you got an exponent sitting here. But that exponent is sitting behind an x plus 3. Now, the biggest mistake I get, people square the x, they square the 3, and they're done. But y'all, let me tell you, you can't do that on that problem. When you see an x plus 3 with a square behind it, that means you better multiply x plus 3 times x plus 3. You got to FOIL when you got 2 terms being added followed by an exponent, okay? So FOIL this out, and then we'll replace that with what we get here. So x times x is an x squared. X times 3 is a 3x. 3 times x is a 3x. And then y'all, 3 times 3 is a 9. And I'm going to add the like terms in the middle so that I get an x squared plus 6x plus 9. We can now replace the x plus 3 squared with that. So I'll have 2 times x squared plus 6x plus 9. And I'm just bringing everything else down. Minus 5 times x plus 3, and then minus my 3. Now, y'all, these parentheses are bugging us at this point. So now we're going to get rid of these parentheses by distributing these numbers in front of them. So the 2, I'm going to distribute through the first parentheses. The negative 5, I'll distribute through the second parentheses. and then I'll bring down that -3. So y'all, 2 times x squared is a 2x squared. 2 times 6x is a 12x. 2 times 9 is 18. Now remember, you got to distribute the negative also. So -5 times x is a -5x. -5 times 3 is a -15. And then bring down that -3. All right, y'all, we got all kinds of like terms here. So the x squared, there's no other x squareds. So I'm going to bring down my 2x squared. So let's look at the like terms. The x's are like terms. 12x's minus 5x's. So that'll leave us, what I say, 12 minus 5. So that'll leave us what? 7x's. Oh, I think the numbers are going to cancel, ain't they? 18 minus 15 is 3. 3 minus 3 is 0. So our final answer is 2x squared plus 7x. Okay, y'all, so I'm going to tell you this number 5 for y'all is going to be tricky because you're going to have a binomial that you got to square. So make sure you foil that on the side and then put it in, okay?
I have a question, sir.
I hear you.
I don't understand how you got g of x.
G of what?
G of x, like the 2 parentheses x plus 3 parentheses squared and all that.
So what the deal is on this one? So let me go back up here. So here's my F and my G. Okay.
Yes, sir.
Now for that one, since we were doing G of F of X, that's like you got a G of F of X. So the thing is, I couldn't do nothing to the F of X because they didn't give us a number down here.
Yes, sir.
So since they didn't give me a number, I got to go into the G function and put this entire F of X in for each of these two X's.
Okay.
And so I would come down, and that's when I came down and I said, okay, well, G of X is 2 times X squared. But remember, X is this whole function F of X, which was X plus 3. So I had to put my X plus 3 there and square that. Then I had minus 5 times X. Well, guess what? X is still the whole F of X function. So I now have to put in the X plus 3 for that X. And then at the end was my minus 3. So look, when you got G of F of X or G compose F of X, it looks like the G function, but it has the F function in for the X's. I still got a 2x squared minus 5 times the X minus my 3. Y'all, it's just that my X ain't X no more. It's the whole function of the X plus 3.
Okay, that makes a little bit more sense. Thank you, sir.
And then in the other one, the F of G looks like the oh, where'd that go? Yeah. F composed G is where I put the whole G into the 1x on the F. All right, y'all, let's see. F composed G of X. Well, F composed G of X is right here. 2x squared minus 5x minus 3 plus 3. What's that domain?
Negative infinity to infinity.
There you go. Because y'all, once again, there's no fractions in that, and there's no way I can get undefined. All right, the domain of G of F of X. So G of F of X was right here. 2 times X plus 3 squared minus 5 times X plus 3 minus 3. What's that domain?
Same.
Same thing, right? Because you don't have any fractions. So it'll be negative infinity to positive infinity. All right, y'all. So the tricky thing on that was you got to do some foiling in it when you're doing your G of F, okay? The F of G, you're just putting the G into its X and adding like terms basically. So, ooh, they get a little tricky if these functions get big like that, okay? All right, now you know they're not going to give us every problem, negative infinity to infinity on them domains, right? So we're still doing the same thing. We're going to find f of g of x, g of f of x, the domain of each. But y'all, this time, look at this. F of x is going to be 2 divided by 1 minus 9x. G of x is going to equal 1 over x. So notice I got fractions everywhere. So let me start out with f compose g of x. Now remember, this is like f of g of x. So I can't do nothing to the g of x. So I take this and put it into the x of the f of x. Okay? So put g of x into f. All right, so that's going to look like 2 divided by 1 minus 9 times x. But remember, x is 1 over x. Alrighty, so now we're going to play with simplifying this thing. Okay. So these ones are sort of tricky to simplify, but to start off, I'm going to multiply 9 times the 1 over x. So that'll give me 2 over 1 minus. Now remember, I'm multiplying straight across on fractions. So the top will be 9 times 1, which will be 9. The bottom, remember, we treat the bottom of a number like a 1, and 1 times x is an x. Now, we're getting closer, but you're not allowed to have a fraction inside of a fraction. So what we got to do to simplify that is try to get rid of these fractions that are inside the main fraction. So to do that, since this fraction has an x on the bottom, and I want to sort of get rid of that x, I'm going to multiply all parts by an x. If I want to get rid of this fraction, I'm going to multiply everybody by x, and that way this fraction will cancel. So y'all, multiplying everybody by x. 2 times x is going to give me a 2x on the top. 1 times x is going to give me a x minus. Now watch this. When you multiply this 9 over x by an x, what's going to happen to the x's? Because see, I'm multiplying everybody by that x. But y'all, these x's are going to cancel out so that I get an x minus 9 on the bottom. And really, that's the only move you have to do to this one is multiply by the x's. Now I got a normal fraction. I got a numerator and a denominator. I no longer have a fraction inside of a fraction, okay? All right, so let me give you one more. Let me put that step back up here where I had 2 over 1 minus 9 over x. So then you can see that I multiplied everybody by the x here, canceled them, and got my final answer. Now let me see. So it does g of f, and then we'll look at our domains. But y'all look at that. This thing had a lot of fractions in it. So we're going to be kicking out a few numbers on that one, okay? So g of f of x, I take the f of x and I put it into my x for my g of x. So g of x is 1 over x. So that'll be 1 over my x, which is the f function. And y'all, that's what, a 2 over 1 minus 9x. All righty. So y'all, I do this one a little bit different than I did that one. Because notice this one had that little fraction inside the main fraction. This one, you can treat like a 1 divided by this fraction. But remember, there's a rule about dividing fractions. We don't like to divide fractions. So we change to multiplication and we flip the second fraction. So instead of this being 1 divided by 2 over 1 minus 9x, it'll turn into 1 times 1 minus 9x over 2. So remember, different methods on, the reason I did different things here, because this fraction was inside my denominator. All righty, so, y'all, 1 times this is just this. So my final answer is 1 minus 9x over 2. And I cannot do anything else to that. So when you do the f of g, yours is going to be similar to mine. So work in how we did this one, and then your g of f will be similar. I think everybody's g of x will be 1 over x. So I did that and in this style, okay? Now, I'm not going to lie. I could have done that one in this style. So let me show you the other way I could have done that one. Because I don't want you to think this way don't work on this one, okay? So say I had g of f of x equaled 1 over 2 over 1 minus 9x. Now I'm going to show you, I can multiply top and bottom by the 1 minus 9x. So watch this. Multiply top by 1 minus 9x and the bottom. Well, y'all, what happens on the bottom? The 1 minus 9x is cancel. And I got 1 times 1 minus 9x, which is 1 minus 9x over that 2. So either way works on this, okay? All righty, so this way would be more like I was doing up here. But you could do it this way, just flip that bottom, multiply and be done. All right, y'all, so let's play some domain. The domain of f composed g of x. All right, y'all, so let me pull that down where y'all can see that top a little bit better. Okay, I started doing f of g right here. So here's f of g. Well, you got a fraction right here, 1 over x. What can this x not equal? All right, y'all, what can that x not equal? What would make that undefined?
0.
A 0. So we know right off the bat, x cannot equal 0, because if it does, it makes this undefined. Now we're working through, and then here's our answer here. Well, what number can this x not equal? What would make this one equal 0?
9.
9. So we know x cannot equal 9 on that one. I got two numbers that the x cannot equal here. Okay. And then that's the only two places I'm worried about. I had this fraction and that fraction right there. And those two had a variable in the denominator. So I had to kick out numbers that made these equal 0 in the bottom. All righty. That means I'm kicking out 0 and 9. So y'all watch, I got to use two unions. We're going to start at negative infinity. Now going left to right, the first number I hit is 0. So it goes from negative infinity to 0. We're going to union around that 0 and kick it out. Now from 0, you're cruising down to x's until you come to 9. So from 0 to 9, and then we're going to union around 9 and kick it out. So notice I had two numbers to kick out. I got two unions. And y'all, from 9, we could head off towards positive infinity. All righty. So now we got to do the other domain, the domain of G compose f of x. So we got to look at this one. Now, it really looks like the only place I'm concerned with is this part right here. Because that's the only place where I got a variable in the bottom of a fraction. Right here, it's on top. I'm good because all that's on the bottom is a 2, and there's no way to turn that 2 into a 0. So for this one, we're only concerned with this part right here. So what I would do there is I would set 1 minus 9x equal to 0. And y'all, we're going to solve that for that x. So I'm going to subtract 1. I get negative 9x equals negative 1. Divide both sides by negative 9. And guess what? All these negatives cancel, making that a positive 1 over 9. So if you put a 1 over 9 here, the 9's cancel. 1 minus 1 makes that a 0. So we got to kick out that 1/9. And y'all, on this one, that's the only number I got to kick out because everywhere else, I got 2's on the bottom, okay? So that means this one will start at negative infinity until we hit 1/9. Union around that 1/9. So we just kicked out 1/9 and we're headed towards positive infinity. So all y'all's domains are going to start with negative infinity and end with a positive infinity. You just got to watch out for what numbers you're kicking out of that, okay? And y'all, I'm not going to lie, these are sort of tricky. You just got to get used to the idea that you're plugging a whole function into a other function, okay? All righty, y'all. So next, I'm going to do a little bit of support. Now, support for 911 only had two problems, although they got a few steps. So this will be 9.1 support. And it's just practice plugging stuff in to get you ready for what we just did, okay? So for number 1, they're going to say given f of x equals x plus 15. I'm going to find f of 0, f of a negative 11, f of a negative 10, f of 13, and y'all finally f of an x plus 9. All right, y'all, let me check one thing. I got someone coming in. I got to see who this is. All right, y'all. So let's play with this first one. So they first want me to find the f of 0. All right, y'all, let me see who this chat is. Okay, the blue. Okay. All right, I got you. All right, y'all. So f of 0 means take my function, put a 0 in for the x. I'm going to have 0 plus 15, which gives me 15. F of negative 11. Well, put a negative 11 in for that x. So you have negative 11 plus 15. Oh, and that's what, a positive 4. All right, f of negative 10. So that'll be negative 10 plus 15. Oh, and that'd be what, a positive 5. F of 13. That'll equal 13 plus 15. And y'all, are y'all noticing? I'm working each one of these the same way. Only thing that's changing is that x on every one of these. And this will be what, 28. Now the tricky one might be the f of x plus 9. I got an f of x plus 9. So I got to put this x plus 9 in for that x. So I get an x plus 9 plus 15. So this is sort of getting you ready for what we did, although we were plugging the whole functions in, so y'all work that one. What's that and give us? All right, y'all, let me give y'all a clue. I got like terms right there. I'm going to add them like terms together. So bring down that x, and then 9 and 15 is 24. Okay. All right, number 2. So number 2 will be a little trickier. On number 2, they're given f of x equals 3x squared minus 4x. They want me to find f of 0, f of a negative 1, and f of 2. Okay. All right, so let's start with f of 0. Now, I got 2 x's here. So for every x, I'm putting a 0. So I'm going to have 3 times 0 squared minus 4 times 0. So y'all, everything's being multiplied by zeros on this. And I'm going to have a 0 minus a 0, which is a big 0. So if you're ever finding f of 0 and you got an x in every one of the terms, it will always equal 0, okay? Now, y'all, what you got to watch out for is this negative 1. So putting a negative 1 in for each of these x's, I'm going to have 3 times negative 1 squared minus 4 times negative 1. Remember, parentheses. You can't do nothing inside the parentheses. So next is the exponents. So exponents got priority over multiplying, dividing, adding, and subtracting. So bring that 3 down. Negative 1 squared is a negative 1 times negative 1, which will give me a +1. And y'all, I'm just bringing everything else down. So the only thing I did there was my exponent. Now I'm going to multiply. 3 times 1 gives you 3. And then look here. That -4 times -1 makes that a +4. All right, then final step, 3 plus 4 gives us a 7. So be careful on negative numbers. The biggest mistake I get is people do -1 and square it on a calculator without parentheses, and they get 3 times -1 here, minus 4 times -1. So that one sign will kill you, okay? All right, y'all. F of a 2. So I'll put a 2 in for each x. I got 3 times 2 squared minus 4 times 2. Now, same thing as this one, order of operations. So the first step is be squaring that 2. So bring this 3 down. 2 times 2 is 4. And then I'm just bringing everything else down. Now I'll do all my multiplying. 3 times 4 is 12. -4 times 2 is what, a -8. And y'all, 12 minus 8 gives me a 4. And that's all you got for support. This support lesson here was really just getting you ready to plug in stuff for that college algebra, okay? All right, y'all. So what questions y'all got on that? I don't know, y'all. I'm seeing no questions. So let me stop my recording and then I'll see what y'all got on homework.